around is fun. But would you try kicking large stones of the same size? No, that would hurt, as you can see. So, remember, the larger the mass of an object, the greater is the inertia. Based on this, if you compare a car and a train, and a plastic coin and a nickel coin, which of these would have more inertia? You would need to compare the mass of each set of objects. The mass of a train is more than the car, so the train will have more inertia. Similarly, the mass of a nickel coin is more than that of a plastic coin. Hence, the nickel coin will have more inertia. Motion states that an object will remain at rest or continue to move at a constant speed in a specified direction unless an external force acts upon it. This law relates force applied on a body to the change in its velocity. There are two aspects of this law that we need to consider. First, an object at rest will remain at rest unless an external force is applied to it. All objects at rest conform to this. For example, on a golf course, a ball on a tee remains at rest until the golfer hits it. When the ball is hit, a force is applied setting the ball in motion. The second aspect relates to a moving object. An object in motion will move at a constant speed and in a fixed direction unless an external force is applied on it. Consider an artificial satellite revolving around the Earth. It moves with a constant speed and in a fixed orbit. The orbit of satellite will not change on its own. In case the satellite is required to change its orbit, let's analyze some more cases where we observe this law at work in our everyday lives. Look at the standing passenger in this bus. The bus starts suddenly and the passenger is pushed back. This happens because the lower part of the passenger's body, which is in contact with the bus, begins to move with the bus. However, the upper part of the body tends to maintain its state of rest. As a result, the upper body tends to fall backwards and the passenger experiences a jerk. Similarly, when the bus slows down by applying a sudden brake, a standing passenger tends to fall forward. This is because, at this time, the lower part of the body, which is in contact with the bus, tends to stop while the upper part of the body resists the change and tries to maintain its state of motion. Rest or of uniform motion. For example, when you try pushing a boulder at rest, it resists motion initially. However, if you exert enough force, the boulder starts rolling. Consider another situation where a truck is carrying an unfastened load. When brakes are applied suddenly, the truck stops but the load moves forward and hits the back of the cabin. This is because the load tries to retain its state of motion. This tendency of undistributed objects to stay at rest or to keep moving at a constant velocity is called inertia. You can see this concept. If a fast-moving striker hits a vertical stack of coins, sometimes only the bottommost coin in the stack is pushed out. The rest of the coins in the stack remain intact. The stack of the remaining coins comes down vertically, retaining their position of rest. This is because no force was applied directly on them.